In this video lecture, we'll be focusing on the branch instruction, which allows us to do program control statements like while, do while, and if. So the first and easiest one to probably understand is if we program something like a do while loop. That is directly analogous from C programming to the assembly language programming of the LC-3 processor. So if we look at this, basically what I want to do is first I want to add register 1 to register 3 and store that into register 2. There's an exact command like that in the assembly. Add R1 with R3, store that in R2. Then I've got a decrement R1 command, which is exactly here. And then I've got this while command, which is basically saying if this condition in here is true, go back up to the top of the loop and execute the top of it again, which is exactly what this while loop, this branch statement here is saying. Is if this is true, if it's negative or positive, which means it's not 0, then move the program counter up 3 spots to statement 14. And then the last command comes after the while loop, which is saying and these two registers together and store into R2. So here again we're going to and R1 with R3, store that in R2. Okay, so let's see how this is going to work. We're going to get rid of all that and look at what we're going to actually have inside our system. So what we have down here is register 1, register 2, and register 3. Those are the registers that we're going to be manipulating in this, so we're going to focus on that. And then we've got our condition codes, N, capital Z, capital P. And so those keep track of what the last operation did. What was its result? Was it positive? Was it negative? Or was it 0? And so when we execute, for example, this decrement operation, I'm going to store into R1. And so basically these bits are going to tell me what is in R1. And then I'm going to have a program counter which is telling me what instruction should I execute next. And then I'm going to have an instruction register which is going to tell me what instruction am I currently executing. So what's going to happen is we're going to go into our fetch phase of our operator, of our instruction cycle, sorry. And the first thing that it's going to do is going to increment our program counter, and it's going to tell the memory to fetch that first instruction. So our program counter is going to increment. Our memory is going to do its thing. It's going to start fetching the operation, and then it's going to store that add instruction into the instruction register. So we've got the add opcode, which is 001. We're going to store into the destination register 2. My source register, first one is going to be 1, and my second source register is going to be 3. Now there's one important bit here as well. This bit 5 tells me that over here is a source register. So after that, we've got our instruction that we're going to implement. Our PC has been incremented. So now we're going to go to the decode phase, which looks just at the opcode up here again. And so this says, oh hey, you have an add instruction inside your instruction register, so we're going to go to the add states in the execute phase of the instruction cycle. And now we actually implement our instructions, so we're going to add SR1 plus SR2 and store into the destination register, which gets us 0102 now. So we add 0100 with 002. So R2 is a positive number, so our NZP says that, hey, R2, our last operation just results in a positive number, so that's what we need to keep track of. And then we finish the instruction cycle and execute and go back to the fetch cycle. Alright, so then we go to the next instruction. It's another add instruction. Our program counter is, we're going to go to the fetch phase of the instruction cycle. Our PC is going to increment. Our memory is then going to send that add R1 plus -1 into the instruction register, and as you can see, bit 5 changes. So it's telling me to look for a constant over here. and I programmed the constant -1 and 2's complement into the immediate 5. So this lets me go backwards, program counter, or I'm going to add -1 to R1. So I go to the decode phase, discover, hey, I've still got 0, 0, 1, so I'm going to go to the add states of my control unit, and I'm going to do exactly what I did before. I'm going to add R1 plus -1, and I'm going to decrement R1, and 0, 0, 1 is still a positive number, so my NZP bits are still positive. We'll go to the next instruction, and now I'm going to do my fetch cycle again, fetch phase of the instruction cycle, and now I'm going to increment PC and load the branch instruction into the instruction register. Now the branch instruction has 0, 0, 0 as its opcode, and this NP down here, we encode that up here saying is if the last operation results in a negative number or a positive number, branch, move the PC back 1, 2, 3 spots back up to executing line 14. And we program that in that -3 inside this PC offset. That's telling us how far we're going to move that PC back up. And so what we're going to do is we're going to go to the decode phase, and during the decode phase there's this long instruction here that's saying set some value branch enable equal to IR11, which is the n, this lowercase n, this is 11, and match that up with this capital N and see what they do. So we're going to AND this with the 0 from the capital M, and then we're going to do IR10 with the 0 from here, so that's going to get me 0. And then we've got this IR9, we're going to AND that with this guy here, so that's AND 1. So 1 and 0, 0, 0 and 0, 0, 1 and 1 is 1, and then 1 and 1 is 1, ORed with anything is 1, so branch enable is going to become 1. So what that's going to do is then after that we're going to go into the branch states, and we'll see that the first state says if branch enable is 1, we're going to go and change our PC. And so branch enable is 1, so we're going to go execute this guy, and PC is going to move up 3 spots because the condition is true. And then we're ready for our next cycle. So the fetch, we go back to the fetch phase, we increment our PC and load our instruction register with the first instruction. You've seen this all before. Then we go into the decode phase, which says, hey, go into the add states, and we're going to execute that. So our R2 is now going to be equal 0, 0, 1 plus 0, 1, 0, 0, and that results in a positive number inside our NZP, inside the last operation. We indicate with a positive P. We go back to our fetch phase. Again, we just keep doing this over each instruction cycle over and over again. We increment our PC and load our instruction, and then we decrement. We go to the decode phase, find that we have an add instruction, go to the add states, we decrement R1, and now this number is 0, so Z becomes 1. That's the big important change here. And now we go into our fetch phase for the branch instruction. So we increment PC, load our branch instruction, and what do we have here? Well, we've got capital N was 0, capital Z was 1, capital P was 0. So we've got 0 or 0 or 0, which is equal to 0. So branch enable during the decode phase is going to be 0. Now, because branch enable is 0, when we get to here, branch enable is 0, we're not going to change PC, and we're going to go right back up to fetch phase. And so we go down here, and then we're going to pull out this AND instruction. So we're going to increment PC and load our AND instruction, which has opcode 0, 1, 0, 1. It's going to have destination register 2, source register 1, 1, and source register 2, which is R3. And we're going to decode and execute that cycle, and you don't need to see that. That's not the focus. We want to focus on the branch. And so as you can see, when it's true, we move up, and when it's false, we keep going. Now, this is some of the stuff that's hard for students to remember. That the reason why this is -3 is because PC is always pointing to the next instruction, so you have to count backwards from that, which is 1, 2, 3. So that's our do-while loop. Very intuitive, very straightforward. This NP matches exactly this command saying, hey, the last instruction, R1 does not equal 0. So this is saying it's either negative or positive, which is all the conditions when that R1 is not 0. That's awesome. That's really cool. That's really good. Now let's look at a different loop structure. We've got our while loop, and this one's going to be a little bit more complicated because the program flow is I start here, I check my condition. Do I want to run everything inside here? If I do, if this condition is true, I want to go through here, hit the bottom, go back up, check my condition, and then if it's false, I'll skip down. So that's exactly what we're going to do here. We're going to have some kind of condition. Unfortunately, if this is backwards of what we want to do, because if this one is false, then it'll execute down through here. If it's true, it's going to skip. So it's going to, but let's do the false case first. So it's false. Then we get to here. This says, hey, go back up to the top, check your condition. Then if this is false, it'll go this way. So this is true. No, sorry. This is the false loop part of this is the false branch. This is the true branch. It's the opposite of what you'd expect from the while. This is the true branch. This is the false branch. So that's an important difference in how we actually program while loops versus conditions in assembly versus C programming. So let's see how this works and why that's the case by doing the example again. So the exact same instructions as before. So everything is going to be basically the same. We're going to make one assumption that we did some instruction before this branch C command, which resulted in P is equal to 1 for the first iteration. So we're going to do our fetch phase where we're going to increment PC and load our capital N, capital Z, capital P. In the decode phase, so we get 0, 0, 1 from our NZPs down below, and then you've got 0 or 0 or 0, which has branch enable as 0, so we leave the program counter alone. So because the last thing was positive, we want to do what's inside the while loop, and so we're going to do this add operation. We're not going to increment our PC, because this branch enable here in the execute phase is going to send us back to fetch. So we're going to go do our fetch. We're going to increment our program counter once again and load our add instruction into the instruction register. We've got our opcode, everything you've seen before. We're going to decode that and go into the add states. And now we're going to add R3 plus R2, store that in, R3 plus R1, store that in R2, and then we'll go back to the fetch phase. We'll increment PC, load our that next add instruction to decrement. We'll decode that instruction and go to the add states, and we're going to decrement R1 based on our instruction up here. And now that's still going to leave my P as positive. And so we'll go to our fetch phase again, and this time we'll load this branch NZP. So we've got NZP. So as you can see here, branch NZP are all 1. So this, but the NZP, when they're all 1, means that I'm always going to go backwards because no matter what, my NZP, one of them has to match. So I've got 0, 0, 1, which results in 0 or 0 or 1 during the decode phase, and branch enable is going to be 1. So I'll go to my branch states. Branch enable is 1, so I'm going to go down, and I'm going to decrement my PC by 4. And then I go back to the fetch phase. So this branch Z is going to be still going to be true because, let's focus. So now this instruction I've got branch on when Z is true. Right now my condition codes I've got 0, 0, 1, which results in 0 or 0 or 0. So during the decode phase, branch enable is going to be 0. I'm going to go to my decode states, branch enable 0, so I'm going to go back to the fetch phase and work on my next instruction. Increment PC, load my instruction, go to the decode phase, run my add instruction, go back to the fetch phase, increment my PC, load that instruction in the instruction register, and then I'm going to decode that instruction, and I'm going to decrement my R1 yet again, and now I've got Z is equal to 1, and that's going to affect my branch, one of my future branches. So we go back to our fetch phase. We're going to pull out that NZP branch. That's always going to be, so it's going to compare NZP with 0, 1, 0, which results in 0 or 1 or 0, which gets me branch enable 1. So PC is going to go backwards 4. And now we'll do another fetch phase. Notice that the Z doesn't change, because the branch function doesn't change Z. So now when I'm checking the condition up here, I'm going to fetch and load my instruction. In my decode phase, I've got 0, 1, 0, which gives me 0 or 1 or 0. And now my branch enable is 1. So when I get here, I'm going to take the PC offset, which is 3, and I'm going to move my program counter down 3 spots to the end instruction. And now I'm going to go back to the fetch phase, and I'll execute that end. So as you can see, the while loop is a little bit more complicated, and that this branch command is the opposite of what you would expect from the while, and that's really critical. The do while is the same as what you'd expect, and while is the opposite. And that's going to be true for other types of design structures, such as the R1 here. This if structure, we're going to do the opposite of what you expect to make that work. I'm going to encourage you to do that on your own. And then similarly, if you want to do an if-else, it starts getting a little bit more complicated. You've got several different branch commands. Again, I'm going to let you figure that one out on your own. I want you guys to learn how to practice these things on your own. So that's your branch instruction. Best of luck.